Now you can see here I have drawn some dots on this on my board. So can I name them? I can name them with A, B, C, D, E, F, G, H and I. So there are different 9 points. How can I join them and draw the different lines? Of course with my scale. I will take a scale and try to draw a line through it. Suppose I have one line passing through this E and F. Okay, I will first draw a line passing through E and F. So this is one line. Don't this make only the line. Remember to do the arrows for that. Then I can see when I try to take A and I on my scale, the third point automatically comes here. So I can have one E also on, F also on that. So now I have one line A, I and joining F. That means these 3 points are collinear, where E and F only 2 points, no other point is collinear with these 2 points. Again I can draw A and B together. See, here is one more line. Again I can draw this B, C and D. See, try to draw the points here and I can draw a line passing through this. See, this line does not go from the B. Can you see? See, this line is not passing through B, but the only 2 points C and D. Then I can join A, H, G. Are they collinear? If they are collinear, I can draw a line, single line passing through them. Otherwise, I have to draw more lines. Again from A, I have joined H, G. I have drawn I, A, E. Can I draw A, I, E together? See, no. Then A, E, I can draw a single line passing through A and E, because when 2 different points are here, I will remember I here. A and E are 2 different points, so I can draw a line. See, I had selected one point A and tried to join every other 8 points. So I have drawn A, H, G is also on that. Then I tried A, I, F, they are also collinear. Then of course A, E. Then can I join AC also? See, of course, because they are 2 different points and I know that one and only one line passes through AC. Can I join AD also? Yes, see here, I can join any 2 points and can take a different line. Okay, so this is another line. Passing through a single point A, how many lines I have drawn? 1, 2, 3, 4, 5 and 6. Similarly, 6 line I can pass through B also. I can join C, B, H here passing through B. Then again B and E also I can join together. Then this is one line. See how many lines you can draw. Now you can take 9 different points on your paper and take one point and try to join it with every other point. Once A is finished, go for another one. Again try to draw and count the lines. See, passing through 2 points, only one and one line can pass through it. But passing through so many points, so many lines can be drawn. But of course, if 3 points are on the same line, they are called collinear and other points are also not. So there will be one like, now here you can see so many 9 points are given and so you can observe that some points are collinear, that means you can pass a line through all the 3 points, or some points are non-collinear. It is not the case. Remember one thing, that only 3 points are collinear, there is no problem for it, but more than 3 points also can be collinear, because on a single line there are thousands of points on it and they are all collinear. So, here you can see a net of lines. One point is joined with each and every other point, and then you will feel that there is a net of lines, and see so many lines we can draw. Okay? So, here again we will try to conclude our line, that is one line. Before that I will go for a point. Okay? So, this is my first concept, this is my second concept about a point. So, point is a tiny dot which can be placed anywhere on the paper by putting your pencil on it. So, point is just a simple, but when all the points come together they will form a figure, and that figures are very important for us in geometry. The second concept is about the line. Now, I can say with the scale a line can be drawn, and this line is line to show that this is a line. See, always a word line is very important. You have to show 2 arrows at 2 ends to show that this line is going to extend at every end. There is no end for this line. And if suppose A, B, C or D are 4 points on my given line, so how I will name the line? I can name that as AB or line AC. How many points you can say? Take any 2 points on the line and you can name them, or you can name like line BD or line DC and so on. Like this you can name by any 2 points on the line, because A, B, C, D are on the same line. That is why you can name like different points. But if that line I cut into 2 parts and I got the segments, then what I will get? The 2 parts, that is I cut this line and have only 2 end points. I will show the points and not the arrows now. Then this is A, B. Okay? So, it can be named as segment AB or segment BA, because A and B are 2 end points. So, I can go from one to another or from another to first. Okay. Now, the third one is about the ray. If the line is cut into 2 parts, that is I have cut one line at this end. So, there is only one point at the end and the other point is going to extend at any distance. So, this point I will name as an end point. Okay? End point of this ray, that is this ray is going to extend in this direction. So, this point will show you a direction in which the ray is going to extend, and this point shows you where it ends, and so this is called as the origin of the ray. While naming the ray, here we are trying to name the figures also. While naming the ray, I have to name them always starting with the origin, then it will be PQ, and if you write like ray QP, then it will be wrong, because Q is not a origin and P is not a point where it is going to extend, but Q is a point where PQ can be extended. So, ray has only one name with one origin, but if there is one more point on it, then you can name it as ray PR also. Then ray PQ, ray PR. But see, what is important is the first point. That first point should be a starting of the ray. The ray starts here. Where you can observe this ray? See, when drawing the figure of a sun, you always try to draw a circle and then see, these lines are there. What these lines means? You are showing the different rays given out by the sun. And so this is the origin of that rays and they are going away from the sun. Like this is an origin of the ray and it is going in any direction. So you have to name the origin first and then the direction, and not any point to the origin, because for segment I can name AB and BA as well, but not for the ray. And again one more example you have, like suppose you have a torch and that torch will show you the rays. See, these are the rays going out and here you can see the light of the rays. Then see here again, they are starting from here and going in the direction unended. So there is no end for these rays to reach, but there is one end at the origin. And so these three concepts are very important. For the line we have discussed three important properties also, that is passing through one point, then passing through two different points and passing through more than two. More than two, when I say more than two, they can be 3, 4, 5, 6, any number of points. So passing through one point, infinity number of lines can be drawn. How many lines can be drawn? Infinity. Infinity number of lines. But through the given 2 points, one and only one line can be drawn. And more than 2 points or more than 3 points, or better I will say more than 2, that is 3. Restrict for the 3. If they are collinear, you can draw a line. If they are not collinear, you cannot draw a line. Okay. So there are two different ways. So to find out the collinear points, you can draw a single line, and non-collinear, you cannot draw a single line. Okay. So these are the properties of the line we have studied. Now some more properties, that is one more property of these figures. Instead of this, we will go now for the next figure, which is a plane. So you know what is plane? In mathematics, plane is a flat surface. You can see many substances in your house, that is some बर्तन है या कोई पिपड़ा है या कोई टीन्स है, they have a curved surface. And some surfaces, like you have a TV, it is having a flat surface. You have a dining table, it will have a flat surface. Here a board is there, a board is a flat surface. But these flat surfaces are part of the flat surfaces. If you can imagine a huge flat surface and cut from it a wooden part to make your table. Okay. So then this will be the plane, which is an original and extended part. So how can I show it? I can show this. So see, this is also a plane surface, but what I have done, I have cut it from my blackboard. From my board I have cut it. So to extend it, I can show it at 4 ends. You can extend, and now imagine the board is extending on the both sides. Once the extension is complete, it can extend on the other 2 sides also, and so there will be a huge playground with this. But that playground is also a part of a plane. So what is plane? only I will discuss that plane is a flat surface. And to show this flat surface, what I need? I will draw a square or any shape and showing these arrows. But showing these arrows are always not convenient for us. So what we will do? We can show only any type of quadrilateral, and I can name it as H. Why H? H is a part, half. If I cut that half part of the flat surface, I will get one plane. So H1 and H2 are the two halves of any plane when you cut by any line. So this is plane. Now this plane I have to relate with these points, lines, segments and so on. Okay. So this is my third one and this is the fourth one. So I can name it as phi. So these are the 5 concepts I have. So now we are studying about the plane. So what is plane? Plane is a flat surface. Can I draw this plane like this? See? And now I want to draw a line in this plane. What type of lines I can draw? See, suppose I have one line, I want to draw this line here. The second one says, yeah, I want a line same way in here only. So he has drawn a second line like this. What type of lines you can see? Both the lines are intersecting in one point. But if I draw a line like this, then see, this plane is extending at all ends, that is all four sided, and these lines are also extending. Imagine these lines are going like this or going like this. Can they intersect somewhere? See, they are not intersecting anywhere, but these two lines are intersecting, this pair is also intersecting. That is, suppose I will name it as AB, then CD and then EF. So one line is AB, line AB I will say, line AB and line EF. They are intersecting. See, AB and EF, they are intersecting. Similarly, line CD and line EF, they are also intersecting. Line CD and line EF, they are also intersecting. But these two lines, line AB and line CD, here they are intersecting. They are also intersecting. But I can watch AB and line CD, they are of a particular type. They have one speciality, that as they extended up to any end, at this end also, at this end also, they are not intersecting. So these lines are non-intersecting. Non-intersecting. These non-intersecting lines in a given plane are called parallel lines. Parallel lines. See, you have to find out if there are, now on my board I will draw lines and you have to say me, are these, they are intersecting or they are parallel. See, these are the two lines. One is PQ and the other one is RS. Are they intersecting? One will say, no, they are not intersecting. See, because in the picture or in the figure, you have not shown them intersecting. But these arrows shows that they can be extended. So you can imagine, can your imagination extend this line? And then if the extended part, I know at this end they will not intersect. But when I try to imagine the line extending at one particular direction. See, this line is extending and this line is also extending. So, somewhere here their distance between them is going to decrease, and then I can say that the lines will be then intersecting at each other. See now what happens. The lines are not intersecting in my figure, but if I imagine extended part of it, then they can be imagined as intersecting. And so, these lines are intersecting lines, though they have not shown intersecting, but we can imagine. Sometimes it is very difficult to imagine because the distance between them is very small, but as you say, see, the distance is like this, and I will feel that these lines will not intersect, but again they will intersect somewhere, not on my board, but somewhere out of the board they are going to intersect, because here the distance is greater and here the distance is smaller. When the distance is not same, again I will come to my A, B and C, D, the distance is same everywhere, so the lines are not intersecting and they are called as parallel lines. Where you can see these parallel lines? On your notebook, all the lines are there. One vertical line as a margin is drawn, one upper line as a red line is drawn, and others are all blue or black. And these all lines are parallel to each other because they are not intersecting also, and so you can imagine such type of figures in the geometry and can study also. Now we will do our practice set. In the first practice set, in the first sum, they have given one figure, and in that figure you can observe a point O. M, T, P, N, S, R are different points, and I have to name the collinear points. To check the collinear points, I want a scale. If I put a scale and can draw a line, then I can say M, O and T are collinear points. Is there any other group of collinear? See, this Q and S, no point is collinear. See, if I can join this, then R, O, N is also another set of collinear points. So, I want to find out the ray. Now, from O, this is, if I imagine this as an end point or the origin, I can have one ray as ON, one ray as OP, one as ON, one as OR, another as OS and one as OT. From all the origin is O, because then only here if I take the P origin, then I have not shown the rays. So, from ray I will say, I will write only 4 rays and you can write all. See, ray ON or then ray OP or then ray OM or ray OR or ray OT, like that. Okay, you go on writing. You can write OS also, because there are, or I will write it so I can also finish the number of rays, that is ray OS. From O, 1, 2, 3, 4, 5, 6 rays are going to origin. Then the line segment. When you want to find out these collinear points only, then you can find ON is also one line segment, OP is also one line segment, OT, OR, OS, they are also line segments, but after that MT is also one line segment, then ON is also one line segment. So, again you can write number of line segments, as I will write here not only the names, but I will write here line segment. Okay. So, first line segment MT, because you can label ON, OP and so on, and the name another line segment. Here I can use only segment also, but they have asked line segment, so I have also written, but otherwise if you write only segment it will be okay, or RN also. Okay, these are the two important line segments, but others are OT. One say OT is also a line segment, no problem, can lie. How many lines are there? There are only two set of collinear points. So I can say the end of two, that is one is line MT and another one is line RN, because these are only rays, they have not extended on the other end, so you cannot name them as a line. Now the second one, this write the different names of lines. Here is one line passing through A, B, C and D. Select any 2 points and name the line. I will write the few names of it, that is line AB or line BC or line CD or line BD, like that. Okay, you can write line AB and line BA also, so there can be more than 10 names also. Now here 1, 2, 3, 4 figures are given in group A, and in group B the names of the figures are given. Can you match them? See, what is this figure? This figure indicates that this is non-ending, so non-ending is a line, so here it goes with the line. So I can answer 1, so this is my answer, match 1 with C. Okay, then the other is C, both is ending, so it must be a line segment, so you can go here. The second can be joined with D point. Then the third is a part of a flat surface, so this is of course a plane, so third goes with the B, and of course the fourth is a one end point and other non-ending, so it is a ray, so here it goes with the A, or you can name the lines also. Here in the 4 question, what is given? See, name the parallel lines. We know what is parallel lines. Concurrent lines. Here we have not seen that the concurrent lines means when a point is given and all the lines are passing through that point. How many lines can pass through? Infinity number. We have seen that. Then that point is called the point of concurrence. So what we want to see, that is more than 2 lines intersecting in one point or 2 lines also intersecting in one point, then I can say these lines are concurrent and passing through one point. So first I will say which are parallel lines. Which are parallel lines? Here you can imagine, see, if A is there, any line is in the same direction, then P. So A line, I will write here again, not only A, but write here line A. Okay, line A and line P. Then another, see, B. B is in this direction. Is there? Yes. M is also in the same direction. Q can be, but little bit difference. You can see whether they are exactly non-intersecting. So I will say line B and line M. Then the second one, that is concurrent lines. See here, you can see line A, B, C are all passing through A. So they are concurrent lines. If only two lines are there, you can say intersecting lines, but more than two lines are passing through one point, then you can say line A, line B and line C. These are concurrent lines, and we want the point of concurrence, that is point of concurrence. At which point all these lines intersect is point A, and so my answer will be point A is a point of concurrence. Like this, we have given an idea about all the basic concepts what we are going to use in our geometry studies, that is about the point, line, line segment, ray and the